no, not again this pager at 3 a.m. Let me see what is happening this time. I don't know why I switched to this job. I get wake up every night now. Let's see what's happening. So there is an error message here on Slack. Prod apps, cache service pod is down. I have no idea how to troubleshoot Kubernetes. Let me call Lucas. He usually helps me.
Hello, Moto.
Hey, Tiago, what's up?
Hey, Lucas, what are you doing?
I was sleeping, man. It's 3 a.m. in the morning. What do you want?
Oh, sorry, I didn't realize that. So you helped me last time. I just saw an issue here on this Slack message that the cache service pod is down. Can you help me?
I can, but I don't have my laptop near me. I will be home like in 10 minutes from now. I'm not home.
You know that you are on call, right?
I'm on call, but that's my problem, not your problem. You know that, right?
Okay.
Let's try to fix the issue. So luckily, the DevOps engineer team has developed a chatbot interface that's powered by GenAI that you can use to get your root cause analysis faster. So what I'm going to do right now is I'm sending a link to that chatbot interface through your Slack, and then you should open that link, and you should be able to troubleshoot that, and I will be waiting here on the line. After you do the troubleshooting, you tell me what you have figured out, and then I can try to fix that issue for you. How does it sound?
Sounds great. Let's try that out.
Okay. So what you need to do essentially is just like go to the Slack message that you received and copy the description and the alert for your problem that you are seeing right now.
Let me just copy the error message and send to the chat here. The date, I will select today. Let's send it here and see what happens.
All right.
So the podding is in a pending state for over 1 minute. No idea what's happening.
Let me know when you get a response back, please.
Sure, I'll let you know. So looking here into the response, it says that the kubectl describe pod. The pod is in a pending state, and with an error message of create container configure, and there is no log events on the pod. So it's also saying that it found a node to schedule this pod, and there is an environment variable called cache config that is pointing to a non-existing config method called non-existing cache config. That doesn't sound right.
It's not right, man. We have a repository template that does the scaffolding for the other repositories, and you know, like, the developers suppose, like, remove that environment variable and then replace with their own config map, but since that the development team has not done that, so you are seeing a false positive, most likely.
Okay, and how do I fix that?
Yeah, let me try to do that. What we can do is we can remove the environment variable from the cache config map since it's not for production use, and then it should be up and running.
Okay, let's try that.
Yeah, let me try to do that. Now I have reached home. We have no acting skills whatsoever. All right, so here we have kubectl get all on namespace prod apps. Yeah, I'm seeing a lot of errors. Let's focus in one by one first. Cache service pod.
I just got alerted by one error, so just fix that one.
Yeah, let's focus on the cache service pod. I'm going to edit the deployment. Don't do that in production, please, folks. On prod apps namespace, I'm going to go down, and then I'm going to search for the environment variables. OK, non-existing cache config. I'm seeing it now. It's a Redis. Let me remove that environment variable. There you go. WQ, kubectl, get all on prod apps namespace, and we should be able to see it running now.
Awesome.
Oh my God, we have fixed the issue. And with that in mind, folks, we're going to introduce the session that we're going to deliver for you today from Logstream Insights. We're going to show you how we have built a chatbot using all the GenAI buzzwords and everything that everybody likes. I'm Lucas Duarte, a container specialist SA in AWS. I've been in AWS for about 5 years, but I have more than 8 years of experience working with DevOps from Brazil to the United States. And here with me, I have my partner in crime, Tiago Reichert.
Similar to Lucas, I'm working at AWS a little bit more than 5 years as well, and I'm covering currently containers for startups in Latin America.
That's awesome. So let's get started with the session, right? So first off, what we are trying to solve here is, I think that was pretty clear with our non-acting skills that we just did in the beginning of the presentation for what we call hook. So basically, the problem is usually the network and operations center engineers, they tend not to have a lot of deep Kubernetes expertise. Usually, we need on-call support to go there and even, like with the minimum amount of details, try to troubleshoot that. I was already in that situation. that gave me the idea to build that session with Tiago, because I was already wake up at 3 a.m. in the morning to try to fix an issue that I didn't have any idea on how to do that. So the problem is pretty clear, and how we are trying to do that, the solution that we're trying to propose here is an automated Kubernetes expertise, so we can empower the networking operations center engineers with guided troubleshooting and real-time recommendations. I've caught myself using GenAI to learn English. I barely spoke English before I moved to the US. So ever since I joined AWS US, I've used GenAI for the past 3 years. And that's the way that I've learned English. How we can apply the same principles that I have done for myself in troubleshooting Kubernetes clusters to do what? To reduce the mean time to repair, which is basically the amount of the total maintenance time divided by the number of repairs. And when we are talking about observability and when we are talking about Kubernetes, there are many challenges that we need to face in order to get to the root cause analysis. We saw that in the last presentation right now. So, Tiago, why don't you take us away into some of the challenges that Kubernetes observability have?
Sure, let's dive deeper into the challenges. So when we talk about container workloads, Kubernetes workloads, usually we also talk about microservices architecture because they work very well together. So let's consider we have a microservices architecture. You might have multiple pods here, even for each microservices, so you have a distributed application. This gets even harder to observe when we talk about add-ons. Add-on is a nice way for you to extend the Kubernetes functionality. For example, having GitOps, having observability itself, and also security. But after you enable those add-ons, you also have to observe those add-ons and make sure that they are working as expected. The same is true for the nodes as well. You have kubelet running on them. You have to make sure that kubelet is working as expected. So looking into a study from logz.io, they observed that the mean time to repair increased over time. So in 2021, 47% of the organizations had a mean time to recover or to repair actually over 1 hour. And if we look into 2024, that number went to 82% of the organizations having a mean time to repair over 1 hour. And that's mainly because of the complexities, as we just saw. So applications being more distributed, you might have cross namespace dependencies, you can have network policies to secure your application, but you can also have issues on those network policies, and something that should not be blocked being blocked. You can have resource blind spots, and so on. So Lucas, why don't you take us over on how we can leverage GenAI to help us?
GenAI, let's go. So that's the solution architecture overview. I know, too many components, so let's do it little by little. Let's focus first on the ingestion pipeline, because as we saw in the last presentation, log quality is pretty important whenever we're trying to get to the root cause of the issue that we're trying to solve. Exactly. So let's move on to the ingestion pipeline. Everything starts with a Kubernetes cluster. In Kubernetes, we have Fluent Bit installed. Fluent Bit is looking not only to the application logs, but it's also looking to Kubernetes events, because since we are Kubernetes experts, we know that a lot of times we use the Kubernetes events to troubleshoot our cluster. We also have kubelet logs from each individual node. As Tiago mentioned, we have information that could be useful for us whenever we're trying to do troubleshooting from all those sources. So what we do, we grab that information, we ship that information to Amazon Kinesis data streams. You could use your own Kafka as well if you are using open source, for example, installing your Kubernetes cluster. After we send that data to Kinesis data streams, we are going to trigger a Lambda function that is responsible to process that particular data. And that is a way to execute code outside of Kubernetes in AWS. And we're using Lambda function just because we have Event Bridge connected to Amazon Kinesis, so it's pretty simple to build that architecture. The Lambda function, we use a model that is useful for embeddings, because we're going to do RAG afterwards. So that embedding model that we're using is Amazon Titan, and what we're going to do, for those who are not familiar with embedding, is we're going to pass the documents to the embedding model, and the embedding model is going to return for us the vectors to the Lambda function. Once the vectors are returned to the Lambda function, we're going to save the pair using both logs and the vectors that we embedded into a vector database. And in this case, we're using Amazon OpenSearch, and that's pretty important. We are saving the pairs because embeddings are unidirectional. We cannot de-embed the embedding, so we need to save the pair and use the embeddings to search. But that's going to be clearer when Tiago takes us away in the next slides. But, you know, in order to customize foundation models to make them do whatever we want to do, there are many different options. And for this particular use case, we have pick rag. But Tiago, can you explain a little bit why we have pick rag and what are the other options that we have?
Sure. So as we will see here in the following slides, as we move here to the right, Yeah, it's your right. You will see that the complexity increases, the quality also increases if you move here to the right with customizing foundational models. But having better quality, you have a lot more complexity, time, and cost usually also related to it. So let's start with prompt engineering. That is probably the easiest way for you to customize your foundational models. So with prompt engineering, it's quite easy. You send a question to the model, and you get an answer. You can do a few techniques here, for example, one-shot or few-shot, where you send, for example, examples on how you want your answer to be, or a little bit of context about your issue so that the model can give a better answer. As we move to the right here, we have retrieval augmented generations, or RAG, more known as RAG. With RAG, we still do prompt engineering. It's pretty important to always do prompt engineering because that will improve a lot your responses from a model. But here we have an additional step that is getting context from a database. In our case, the OpenSearch database that Lucas just mentioned. So we get relevant logs to that specific issue that the person is asking to troubleshoot as context and pass that to the model to get a better troubleshooting related to the context of my current application. For example, the error logs from the application. So moving forward, we have fine-tuning. The idea of fine-tuning is for you to get a model as base and make that model more knowledgeable in a specific area. For example, industry. You could, for example, want to have a model that knows more about financial industry or healthcare. You can get a base model, use a fine-tuning job, for example, with a lot of data sets related to that specific industry, let's say financial, train that on top of GPUs, and at the end, you have another model. And with that model, you can do, again, RAG and also prompt engineering, as we saw before, but now with a model that is more specific to your use case. For that, again, you will need a data set with data related to that specific industry that you want to train, and also GPUs. And last, we have training your model from scratch. That's also possible. What changes here? You don't have a model as source at the end.
You know, Tiago, I don't think that diagram looks right for training the model from scratch.
Actually, it's like this.
Much better, much better.
If you train your model from scratch, you will probably need a lot of data set, a lot of data to train your model, and also a lot of GPUs. And that can get expensive as well. So usually we don't see so many companies training their model from scratch. We see more really fine-tuning those models. Of course, you can train it from scratch. There are some companies that focus on this, but it's not a good use case for all cases that we see around. So now that we understand how this works, let's dive deeper on how we use RAG for our use case here. So let's consider that architecture that Lucas just showed to us. Let us now focus on the other part of it, this chatbot at the end of the application, or the bottom of the architecture. So considering this chatbot, we have here our user that is trying to troubleshoot an issue, see what is happening for our application, and we have that OpenSearch database that Lucas just showed to us. How do we connect those dots? So the user will send a query. For example, why is my application, my payments application not working? We have to embed that question using the same model that was used to embed the logs. That's very important. If you use another model, your query, your search for the context will not work. So use the same model. It doesn't have to be necessarily this model, but use the same model for embedding the logs and the query itself as well. And then you have this embedding, a vector of numbers that you can use to search on OpenSearch. That search on OpenSearch will return to you the context. Again, remember that Lucas mentioned, we cannot get back from the embedding to the log itself. So we just use the embedding to search in the database, and then we return the log itself, the text of the log message itself. And that can be used for our augmented prompt. So we have now the context of the application, the logs of the application. We have the question from the user, for example, troubleshooting a specific issue. And we can pass that to a model. It could be, for example, on Bedrock. It could be, in our case, in this architecture, we have DeepSeek running inside of the Kubernetes cluster as well that you can use to troubleshoot this issue. But Lucas, I think we can make this more smarter. How can we improve that model or that workflow?
Let's talk about agentic workflow, since it's a term that a lot of people are talking about right now. So with this architecture that we have, could be good enough maybe for 30% or 40% of the problems that we see. If we can empower the networking operations center engineers, at least with the minimum that they can give to the on-call support engineer to fix the issue, that's already good enough for me. But we went one step further in this architecture. We are calling that first response intermediate response, and we have a prompt engineer to that first prompt where we ask the model to generate kubectl commands, and it knows which commands to generate because we have context from OpenSearch that were Kubernetes events, application logs, as you saw. That intermediate response will generate kubectl commands. We're going to parse those kubectl commands using regex because on the prompt engineering we have been very specific on the way that we want the model to generate those commands. Once we parse those commands, we're going to execute those commands on the Kubernetes cluster. And then once the commands are executed, we're going to generate a new prompt to send that back to the model. And that new prompt will contain what? kubectl output plus the intermediate response. It's pretty hard to say some words when you speak Portuguese. Intermediate response, and then the first prompt we'll have is basically the augmented prompt, the first query that our user initially has sent to the model. Once it's done, we pass that all back to the models that we choose, and again, we can use, in that architecture, we have Claude on Bedrock deployed, and we have DeepSeek running on VLLM on top of Kubernetes as well. We pass that back to the model, and then we have a final response. We are basically the hook that you saw in the beginning of the presentation. So that entire workflow have ran, and then we got the final response after that workflow has ran. One thing that I want to add here before we go to the demo is basically we could iterate on top of that workflow and ask our model to generate more commands and be more specific into the troubleshooting.
And that will get more clear during the demonstration as well.
Exactly.
How that would work.
Yeah, so we could do that, and then once we are in the code, I can show that to you folks. But now with further ado, it's demo time. This QR code right here is to the GitHub repository where we have the full implementation open source. It's all Terraform, so you can do a Terraform apply. It's going to deploy in your environment. You can try it out. We are not developers, so please, we're accepting PRs. We're DevOps engineers. And then I think now it's demo time. We're going to show the QR code after the demonstration as well. So, Tiago, take us away.
Let's go to the demonstration. So, what we can do here in this chatbot is a pretty simple interface. We just select the date, and it's important to notice that that date actually defines which index we are using in OpenSearch to search for the logs. So we're indexing by date, but you could index that by hour or by any time frame that makes more sense to your use case. We don't have a lot of logs being generated here, so indexing by day worked well for us. So here we can send a question. We also select the model. So let's ask why the payment service app is not working. And let's see what it answers. So after we submit here, if we look into the logs of the application, we will see the user input. So why is the payment service not working? We can see the context that was found in OpenSearch. And here we can see that it found a specific pod name and also in which namespace that pod is running. Looking into the initial response, we can see the kubectl commands that were generated to further troubleshoot the issue. And if you look into details here, you will see that we have that specific pod name and the namespace that we did not pass in to the initial request, and that was generated based on the initial context that we have from OpenSearch, from the logs of the application itself. Afterwards, we parse those commands, and we have a list of the kubectl commands that have to be executed. We run those commands against the cluster, and it's very important here. You might be asking yourself already, this is no write access. We just have a service account with read-only access, so just get pods, describe pods, and also no secrets access so that you don't have access to the secrets. You could for sure also tie this service account more down to your use case as well. So we run those commands, and then we use that again as context and pass that to the model, having both the logs, the user input, and the output of the kubectl commands, and we get an answer back. In this case here, it's saying that this pod is in a pending of image pullback currently, that the repository probably does not exist. And here are a few options that you should look into to troubleshoot this issue. So check if the image name exists, check if the repository exists, check if you have permissions to that repository, and also if there is maybe an issue with connectivity. Let's now change the model to DeepSeek just to see how this changes, because DeepSeek has this reasoning behind its training, and that gets very clear when we send a request to DeepSeek and can see the answer that it generates. So you can see that it starts to break the problem really into pieces and explains how it's answering or how it's generating the troubleshooting for that problem. In this case here, it's saying that probably that image does not exist, and you can see the name of the repository is non-existent, so it's pretty obvious what is the issue in this case here. And it also says how to troubleshoot that issue. So it says here, for you to further troubleshoot, you could do, for example, a Docker pull to that repository to see if that image really exists or not. If it does not exist, you will probably get more information on why it's not being able to pull that image. So this is just a short demonstration of how it works. Again, it's a pretty simple architecture. We just wanted to show you how to really use RAG to get these insights and troubleshoot issues with your application. Lucas, can you take us over now to how the code looks like?
Yeah, let's take a
And again, just a note, we are not developers.
Yeah, let's take a little look at the code. I just want to say that better. I'm not seeing the other screen
And
for some reason.
while Lucas is going to the code, that part that Lucas mentioned that we could, for example, iterate more, we just could get that output from the model itself that we saw on the screen and ask further questions there in the chat and pass that as context to the next question. So let's say, for example, you said for me that it could be a network issue, it could be a credential issue. So give me the comments to test that route. Or what should I do to test if that's really the issue? So we can improve this chatbot as well.
And another thing is, as we saw in the last presentation, the better log quality that we have, better RAG we're going to have to grab the context, and better troubleshoot we're going to have. So log quality is something that's pretty important. It's being discussed everywhere, and now we can use GenAI for a little help. I'm going to go pretty quick on this demonstration. I'm going to show the QR code for the repository at the end as well, and you can feel free to try it out, open PR, reach us out on LinkedIn. But let's take a look into the code right now. As Tiago said, we have the index name, and we are searching, and we're creating one index per day. We could have one index per cluster per day, and we could have multiple clusters in the same vector database, and we could use the same chatbot to search across all the clusters if we want. In this case, it's just a single cluster. So the first thing that we need to do is embed the queries. And as you can see here, we are using a function called encode query, and that function, it's basically calling Amazon Bedrock using Boto3 to embed the context using Amazon Titan. And then we return the embeddings to our main application. And as you see, yeah, that happens. Cool. So once we have the encoded query, what we do is we have created a class called OpenSearchClient, where we have a method called retrieveDocuments. That method, retrieveDocuments, we receive the embedded query, the index name that we want to search, that we build on the beginning of the application when we first initialize it, and we're passing two parameters here that are pretty important. The top K, we're going to give us the amount of context, the amount of logs that we want from OpenSearch, and the minimum score, which is basically the minimum similarity score. Bigger it is, more similar the logs needs to be.
And why is it important to have this limitation of amount of logs that we return?
That's a really good question. It's important to have log quality and limitation on the amount of logs because we have something in the models called context window. So depending on the model that we pick, the context window could be smaller, so it's better for us to understand what we are sending to the model before we explode the context window. So that's a way to avoid that problem to happen. So after we search the documents on OpenSearch, we're going to retrieve a list with retrieve documents, and then we're going to build our initial prompt. And this is what I want to show to you, folks. That's pretty important. We have the retrieve documents, and then this is the prompt that I was telling you that we have put in the model to generate kubectl commands. So I'm saying to the model here, generate kubectl commands whenever is possible under this key, so we can use regex to parse, and then we can execute those commands. And then we create the prompt, and that's pretty important. The prompt structure, it's something that really matters when you are working with GenAI. So being very prescriptive, again, Portuguese, prescriptive, and having that in a structured way, it's
Start always with prompt engineering before you go to fine-tuning or something like that, because that will be important anyway if you are doing fine-tuning or RAG as well.
Exactly. So then we send that prompt to our function called generate response with kubectl. We pass the prompt, and then we pick the two models that we can pick, Claude or DeepSeek. Let me just open it up so you can see what we do. We parse those commands that were generated by the model. We execute those commands. We combine the output in that new prompt, and we call that a follow-up prompt. And here on the follow-up prompt, we say to the model, please don't generate any new kubectl commands for us. We could ask the model to keep generating, and we could iterating and keep talking to the chatbot to get to the root cause, but that for that particular use case, we are just generating a single command and then returning the final answer. So I'm going to go back to the presentation slide, and we have some key takeaways here before we finish this session. So the first thing is, we want to empower the network and operations center engineers because we know that often those folks don't have a lot of Kubernetes deep expertise. So if we can teach them using a model with our own context, even better. But all that to reduce
the mean time to repair. So the whole idea here is to get your applications troubleshooted as fast as possible and reduce your downtime of the applications. And for that, we also introduced an agentic workflow because we know agentic AI is being talked all over right now. But the idea here was to bring a real use case that you can really leverage agentic workflows to get further troubleshooting, get more information about your issue to troubleshoot your Kubernetes cluster.
That's it for today, folks. We really appreciate our time here with us today. That's the QR code for the session survey. It's pretty important to fill that up so we can improve for the follow-up conferences that we're going to present. 2 QR codes to our LinkedIn as well. So if you want to follow us on LinkedIn and talk to us afterwards, that's fine. And then, once again, as promised, GitHub repository, the full implementation, we're accepting PRs, give it stars, forks, and everything. And thank you so much.
Leave the other one. Leave the other QR code a little bit more. And folks, may I just ask you a quick thing? Let us take a picture.
Please. Please.
Thank you.
Thank you to our speakers. We can do one question. So we have a mic in the middle of the room. So please come to the mic if you have a question. And yeah. I think I saw a hand. Yeah, we have a question.
Sorry. I'd like to know, I'm not completely sure if I understand it right, but does the logs go to the model and the model is retrained with it? And if this is the case, how often is this done?
So
Can you hear me?
Yeah.
Oh, awesome. So the logs, they are not sent for the model to fine-tune or to improve the model itself. We just use it as rags. So we just get the context of the logs because logs, they are really like ephemeral. You want to have something that is like from the last few minutes or the last few seconds. So instead of always fine-tuning the model itself, we just get the most recent or the logs that are related to the issue that you want to troubleshoot, and we pass that in the request, and it's just used as context during that request. It's not used to fine-tune the model itself.
But
the model does not learn.
One thing that I want to add is if you have your own troubleshoot guidance, your own log structure, you might want to fine-tune a particular model into your own use case, and then the response would be better. But you could keep using the same workflow, but instead of doing RAG, you could even do RAG plus the fine-tuned model to get an even better response.
If you have a documentation, for example, on how to troubleshoot your own environment.
Exactly.
Thank you.
Awesome, thank you.